All right, today we have another spicy video on microservices versus monoliths, and in particular, modular monoliths. Before we get started, let's take a look at this quote from Jason Warner, who is the former CTO of GitHub. I'm convinced that one of the biggest architectural mistakes of the past decade was going full microservice. On a spectrum of monolith to microservices, I suggest the following: monolith, apps, services, and microservices. Okay. Now, this isn't to say that there's no place for microservices, because that should not be your takeaway from this video. There's obviously places where microservices make a lot of sense. And typically those use cases make sense when there are boundaries. Those boundaries could be process, organization, or technology, or regulatory boundaries. And in these cases, it makes perfect sense to break apart your application into these services to align them with the boundaries of what you're trying to do. Okay. Where it doesn't make sense is small teams or startups where there's only 5 or 8 engineers and they're all working full stack. It doesn't make any sense to break those apart because you don't really have boundaries, right? You're all working together on one set of, presumably one set of applications. The exception to that maybe is regulatory and technology, right? Because in some cases, for example, you might have a piece of code that's running that's better in Python, one piece that's better in Java or Go or .NET. And of course, if you're in a regulated space, you might have code that needs to be run in a more secure context versus other code. Okay, so I don't want you to walk away from this video thinking that there's no places where you should use microservices, because that is not the case. You just have to really understand why it makes sense. Okay. Now, the core problems with microservices, there's, this Google paper in 2003 titled Towards Modern Development of Cloud Applications is a really great paper, and it does a great job of outlining, really readable paper, and does a really great job of outlining the key problems and challenges with microservices and how it affects DX, iteration and development velocity, and correctness and all those things, right? So let's break it down, okay? Number one is it decreases performance, and this is really obvious, right? Because now once you have different parts of your application talking as services, you have a service boundary, and you might have a network traversal and routing, and then you'll also, of course, have serialization and deserialization on both sides. So now it hurts the performance of your application versus if you just linked that binary directly, right? It hurts correctness, right? You have, lots of services. They might have different versions. Some might be up, some might be down, some might be slow, some might be fast, and some might be under load pressure, right? You have this correctness of your system is harder to really understand and grasp, okay? It's also harder to unit test the whole thing, right? Because you have code that might be sitting in completely different repositories, and you can't really test the whole thing. It's hard to manage, right? Again, if you have 10 microservices, you have probably 10 container images that you're managing and you have to deploy, right? It becomes really challenging to make sure you're deploying the right versions of the right images to the right environment with the right configuration, right? Everything becomes more complicated as you increase the number of moving parts. It freezes the APIs, right? So we all know this, like if you pull this contract from this service here, now that service changes its contract, you have to either come up with a versioning scheme or you have to update your reference before you can continue on. And then it slows development because you can't just one click and debug through your whole application and step through it. You have to potentially deal with each independent piece separately, okay? And even just starting up the application, you might have to start 5 pieces. Versus with a monolith, what's really nice about it is you just hit one button, the whole application starts up, and you can just go, okay? The central point that the Google paper makes, and really what makes it possible for us to build this modular monolith, right, is, teams fail to make this distinction between, teams fundamentally, conflate these logical boundaries, right, how the code is written, with physical boundaries or how the code is deployed, right? And this is something that we really have to think about and is the central point of this talk and the repository and the project that I'm going to go through, is really talk about code organization versus deployment model and how these two things are really decoupled, okay? And this will really allow you to build applications that are scalable, that are secure, but are and modern, but still monolithic. Okay. Now, again, let's talk about what a typical microservice looks like. A typical microservice looks like this, right? You'll have your maybe admin service, your reporting service, and your API service. And these pieces have to talk to each other through RPC. So be that REST or gRPC, you have a service interface, and you have serialization and deserialization. But what you get is you get isolation of the boundaries of each of these clusters or families of nodes, and you can scale them and secure them independently. Okay. Now that's really what microservices give you, right? Is the ability to scale these applications independently, these parts of your application independently, and secure them with different sets of rules. Like your admin service might need different security configuration compared to your reporting service. Okay. Can we achieve this with a monolith? Of course we can. It's really easy, right? We just deploy the monolithic code into these different boundaries, right? Let's say, for example, this is a Kubernetes cluster or this is a set of pods here, right? We can still do that with a monolithic code base. There's nothing stopping us from doing that. And then building the boundaries as needed, right? Now, how do we do this practically? Okay, well, you can probably take your existing code base and already ship it as a modular monolith if it's a monolith. The reason for that is because, as developers, we don't always think outside of the scope of the runtime. But in reality, if you're, any modern application you're deploying into AWS, Azure, or Google Cloud, you can really just fake this, right, to some extent with the load balancer. So, for example, if you deploy identical copies of your code into all of these layers and all of these nodes, all you've got to do is, configure your DNS and your application load balancer so that hosts with adminexample.com go to one set of nodes, reportingexample.com go to a different set of nodes, and APIexample.com go to a different set of nodes. And now you can scale those nodes, in and out, up and down, secure them with different network rules and security rules completely, right? And you're done. You have to do nothing. You can deploy your monolithic code base as a independent and scalable set of services just by doing this, right? Now, why this may not be obvious to a lot of folks is people sometimes, a lot of teams, they don't operate at this level, right? You have to come up one level to think about, the runtime configuration and network routing of your requests to be able to do this, okay? And in the past, this was expensive because you'd have to provision and buy your servers beforehand, right? That's not the case today because, you don't have to wait, 4 weeks to get a new server if you need to scale it up. You just go get more server. You just go get another ECS node, right, or EC2 node, perfectly fine. So we can do the same thing with, we just break out the modules and each node contains the code for all the modules. But what we'll do is we'll just load different pieces at runtime. We'll virtualize these roles and we'll take a look at, in detail how we do this, okay? What about the local development experience? And this is one of the key points of the paper, and what it points out for local developer is the programming model enables a developer to write a distributed application as a single program where the code is split into modular units called components, okay? And we will take a look at how this is done practically, okay? But this is really key, is this really improves the developer experience when you have a monolithic code base, because now you can just hit run and the entire application starts up and you can debug and step through all of your code, right? Versus in a microservices world, you'll have multiple services. It's much harder to trace a single request through all of these applications or these parts of your application versus just tracing it through your code base, okay? And, really, really key to how we achieve this is, in the Google paper, it says, right, we separate how we write the application from how we distribute the application, okay? So what you're thinking now is, okay, people don't do this because it's hard, right? And in fact, it could not be further from the truth. It's incredibly easy to achieve this, okay? And that's part of the reason why I wanted to build a practical example of how to do this that has all of the scaffolding and, maybe tricky parts done for you, but I promise you, none of it is hard, okay? And if you want to see for yourself, grab this QR code. It points to a repository that has all the code that you're going to see today, and you can dive into it yourself, okay? And the key points we want to cover are code organization, development experience, or DX, refactoring, debugging, runtime deployment, partitioning, and extending for your use cases, okay? Now, before we dive into the example, it's going to be useful to kind of understand the use case that we've built for this sample. What it really is there's an API connected to a Postgres database, and when an item gets added, right, there's a worker, a background worker that's checking when items are added, notify collaborators on that project, right? And when an item gets completed, we have another background worker that's going to update the status of the project, check and update the status of the project when the individual items are completed, okay? Now, we're just directly connecting to Postgres because it's easier for this example for you to get it up and running. But in the real world, we'd probably be publishing messages over a service bus like Google Cloud PubSub or SNS SQS or Azure Service Bus, okay? But for the purposes of this example, to keep it simple, we are just using the Postgres database, okay? So this is the context of our application. We have an API to create projects, users, and work items, and reporting and admin, and then we are going to monitor when things get created or added and changed, okay? And you can access the code base here, but what's really kind of important to understand is we're going to dive into the organization of the code and talk about how this code is organized and really look at how we interact with this as a development environment, okay? So with that in mind, let's dive into our code, and you can see here this code base is really organized into a source repository here, and in our SRC repository we have a common project that has our data models, and all of our data access code is here. We have a core project which has our controllers and the primary logic for setting up our background services. Our background services are here. And also our setup code, how we set up our runtime host. And we're going to talk about this in a moment. There is a reporting module here, which I've broken out just the reporting controller and endpoints. But in reality, this controller can just go into the core. You don't have to break it out. You might want to break it out for the purposes of your team and organization. So this is just an example. And in fact, you can also break out admin controller if you want, and project controller. However you want to break it out, you can break them out into separate projects. You don't have to, okay? And finally, our service host. And we're going to look at this really closely in a moment, okay? Then we also have our two Docker files. One Docker file for packaging our, let me bring this out over here so you can see it. One Docker file here for packaging our application in a way that we can emulate the upstream runtime environment where it would be in GKE, for example, or ECS, okay? In this other one, this will just bring up our development Postgres databases so that we can run our application against this Postgres database, okay? And we'll look at these, but the first thing we really want to do is let's talk about these programs, right? And what these programs are, in the .NET world, there's this concept of application and runtime hosts, okay? And what hosts are really runtime containers for services. And what we can do is in each of these hosts, we can load different sets of services. So for example here, this SVC service is the service that we're going to use to host our runtime, our background runtime modules, right? And you can see it's really simple. All we're going to do is from the environment, we're going to get a role. And based on this role, we're either going to load this service, or we'll load this service, or if no role is specified, we'll load both services, okay? So when we move this application upstream, we're going to have one host that is just dedicated to our background services. And the reason for that is because then we don't need to expose any of the HTTP endpoints from this particular host. This host will just run background services. For example, the services that might be connected to your SQS or to your Azure Service Bus or to Google Cloud PubSub, okay? On the other side is a little bit different. Here you'll see on the right-hand side, we've built a what's called a generic host, right? On the left-hand side, we're going to build a web application host. And the only real difference is that this host has some facilities for HTTP handling already configured, plugged in, and set up. Otherwise, underlying it is the same host model, .NET host model, which is really, really convenient. Okay, this code looks very similar and is pretty much identical, and we're just reusing the code. Okay, and in fact, if you look at the SVC project over here, what you'll see is that it's mostly empty. There's really no code here because all of the code and logic is being imported from the other parts of this application. Okay, and if we come back here and just look at the dependencies, right? This SVC background worker runtime requires core and the common library, and the core library has dependencies to common and reporting, and then reporting has a dependency to common. This is where our data model is sitting. Here's our reporting endpoint. Here's all the other endpoints and our background workers, and then here's our service runtime host just for our background workers. Okay. Now, what are we actually doing here, right? Again, we have a set of services you can see here, an admin controller, right? A project controller, a user controller, a work item controller, right? And what we want to be able to do is we want to be able to achieve certain things. Is based on the role of this individual node, right? We want to be able to load a set of services at runtime, right? Whether those are API endpoints or those are our background services, okay? But at dev time, local development, ideally we just load everything into one runtime because that makes life easy. And that's exactly what this setup and the scaffolding is going to do. So at startup, you can see here, if we come back to our program here, right? We have this add custom services here. And what we do is really simple. If the runtime is development, then we are going to load both our background services into our runtime. So we have our background services in our runtime. Okay, perfect. Because now we can step through it and we don't have to start up another host to run the background services. Okay. What about our controllers? Okay. Our controllers use similar logic. Is we're just going to read environment variables. And if we find that we want to enable admin routes, okay, we want to enable default routes, or we want to enable reporting routes, right? Then we can load those routes separately, load those services and endpoints separately, okay? So for example, here, if we load admin controllers, we can just enable that type of controller. That's it. If we are loading the API controllers, let's just load the API controllers, right? If we are loading the reporting controllers, let's load that. But look at what happens, right? If we don't specify any of these, as is the case for our local development, we'll load the default. And by default, by default, we just load all the services, right? Instead of loading specific services, okay? So it's really straightforward. And all we needed to do is copy out some code from a Microsoft GitHub repo, which is the code for how, ASP.NET itself loads services. So we just take a little bit of code from how ASP.NET itself by default loads services and customize it so that we can control which services we load at runtime into the host, okay? Now, practically, what does this mean, okay? First, let's bring up our Docker container for Postgres. And now we can run our application, okay? Now, pay attention here. When we run the application, okay, we can see here, we load all controllers and we start both services in one binary, right? So in development, there's only one runtime, one binary, and we've got everything. And here, what we can see, our localhost is at 5228, okay, double check here, 5228. And here we have our services. Our default API, excuse me, our default API has our projects, endpoints, user endpoints, and task or work item endpoints, okay? Our admin API has our deletion endpoints, right? Just as an example. And then our reporting API has our reporting endpoints. So we can break out our services into our different endpoints. And now we can load them all together in one runtime, or we can load them into separate, into separate runtime classes by role, okay? Now, One thing to keep in mind is that this does take a little bit of configuration to make it work. And really, a lot of this logic is sitting in this setup Swagger extension. And in the setup Swagger extension, you can see what we're really doing is we're trying to break out the different services into our main API, our admin API, and our reporting API. And you can dive into the code and look at it yourself to see how this is accomplished. But the gist of it is that we are using some of the Swagger configuration, and then on our actual API endpoints, we just define the API group that it belongs to. So this is the admin API group, and then if we go down to reporting, reporting has a different API group as well. And you can see here, this way we can break out our Swagger or OpenAPI specifications and have completely different sets of APIs coming out of one assembly, right? So that's really, really handy, really powerful, and really allows us to have a lot of flexibility with this, okay? Now, let's talk about running this, okay? So what's really great here, you see, we just run this and the whole application comes up, right? But of course, because this is just a normal application now, I can just start it by hitting this debugger, and the application starts up in debug mode, and we're ready to go, right? The whole application is ready to go. And our endpoint comes up, right? But look, we have this breakpoint set up here in VS Code. And if we hit this endpoint, let's come and hit this endpoint here. We're going to hit our endpoint 5228 here on reporting. Okay? We're going to hit our endpoint here, and let's watch what happens. Look at that. It's perfect. Even though this is sitting in a different assembly in our project organization, we are able to step into it as a, just a part of our code base because it's all running in one runtime, right? One executable, one runtime. And this makes working with the application really, really easy, right? And we can do that regardless of our endpoints, right? If we come back up here, let's take our user endpoint here, and let's do one of the easier ones here, project controller. Let's do user here, right? Let's add another breakpoint here and here, and let's do it again, right? Let's just hit this. We'll start our application in debug mode, and now if we come back again, okay, if we come back again here, this route is API users add, right? API users add, okay? And here, oops, API localhost 5228, API users add, okay, get, what do we get? 405 method not allowed. So here, API users, oh, sorry, just users, not add, okay? There we go. We stepped right into it, and we can just debug this like normal code, right? But at the same time, right, we can also do our reporting, okay? So this is really, really handy because it makes the local development experience much, much better, right? I don't have 5 services, 6 services to start up. I only have 1 service to start up, and I have all of my application loaded, and I can step through it with the debugger, okay? Now, the other really critical piece of this, why, when we talk about correctness and iteration speed, right? Because these dependencies are linked as binary dependencies now, and they're not service contracts, right? If I come and update my model here, for example, right? Let's copy this field here and date, time, and let's do this, start date, right? We've added a required field for start date, right? But now, as soon as we do this and we come to our controller here, we have a problem, right? We know right away that there is a problem here because we are missing this required property, okay? And because this is, just a normal binary link, binary dependency here, if we remove it, we fix it, right? Similarly, if we change the name of this property, right? Current status, we can use all the tools at our disposal for doing refactoring. It's way, way easier when it's a binary dependency versus a service, an external service dependency, right? It's just straight up easier and faster from a DX perspective, okay? Now, let's come back here real quick and let's talk about our end result, okay? We're gonna go back into code in a moment because I wanna show you how we actually break this apart at runtime, but let's talk about our end result. We've increased performance, right? Because our application, all of our dependencies are linked as binaries now. They're binary dependencies. They are not service boundaries. We don't have to serialize and deserialize, right? It improves correctness because we're only deploying, there's only one container image, two container images in this case that we're going to deploy, but we could collapse it down into one if we want. So we always know we have the most current version or not, right? It's really easy to manage because everything, you only have to build one or two container images and everything is going to be deployed atomically, right? The logic for, the backend logic and service logic for your admin, users, reporting, it's going to be deployed atomically every time, right? You're not going to have version mismatches. And you don't have API surface area to maintain between your services. Your services are direct binary dependencies, okay? And you really accelerate your development lifecycle, right? Because you don't have to have all this extra work to start up your local development environment. All you've got to do is, hit play and start the application, okay? Now, what does this look like upstream? Okay, that's the next question is, what does this look like when I actually deploy this into Kubernetes, or I deploy this into ECS, or Azure Container Services, or GKE? Okay, so within this project, I'm gonna stop this container here. Within this project, there are two Docker files, and these two Docker files are what you want to look at, and these are examples to replicate the upstream runtime environment. And this Docker file here is the one that packages the API runtime as one container image, and this one here will package the other container, which is the background services runtime. Okay. So what pulls this together is really this Docker file here. And in this Docker file, what we've got is we've got each of our services, right? We've got our API, one API here. And this API, this set of nodes here, will run the default API routes and the reporting routes, right, on port 8080. The admin service will run the admin routes on port 8081. And then our two background services, you can see all we've done is we've taken the same Docker image, and we're telling it, okay, you're going to start up and only run this service, right? You can run this service, and you over here, you run this service. What this allows us to do in practice, if you think about this upstream, is that we can configure different types of pods or different types of servers, right? Or instances, depending on how you're deploying this, based on the needs of each of these services, and we can scale them and secure them separately, okay? So let's start this up, right? I'm gonna fire this up and let's take a look at it. Okay, again, you can do this yourself. Everything is here. You just need Docker on your local environment. And here you can see what we've done at startup is, look, we've got API 1 starting up, loading the API controller and the reporting controller. And we have the admin API, instance starting up with just the admin controllers, right? And then we have service 2 and service 1 starting up, loading two different sets of services, right? Okay, and our application is now running, right? Let's take a look at what happens at the front end. On the front end of the application on port 8080, if you remember, that's our main API and our reporting endpoints. You can see here, if we try to load the admin API, there's no operations in the spec because we're not publishing those services from this module. We haven't loaded them at all, okay? But we do have reporting and we do have our default API. If we come to port 8081, this is where our admin endpoints are running, and we don't have our default API, we don't have our reporting API, but we do have our admin API, okay? So if we want to now, we can secure this set of nodes with a different set of security boundaries, different set of API gateways, whatever the case may be. We can scale this down a little bit more because we don't have as many admin users, but we can scale our default instances up more, okay? Practically, what does this look like at runtime? Let's take a look and make sure that this is the real deal here. We're going to curl the local host, but what we're going to do is we're going to do 8080 here. Let's do 8081 first, okay? This is the one that's running only our admin code base, okay? So if we try to hit 8081, you can see we get back a 404 not found. That's because those routes are actually not loaded into the runtime, right? So you actually cannot reach those routes, okay? Again, there's different models to achieve this. One is you just virtualize it and say, okay, I'm going to load all the code into all the runtimes. That's totally fine too. And you just virtualize it using your load balancer and request routing, okay? But in this case, what we've done is we've actually traded this, okay? We've actually configured this so that at runtime, some of our instances can run certain types of services. Some of our instances will run other types of services in the same host container just based on configuration, okay? So what does this look like in practice, right? I think it's going to be really helpful, actually, if you actually see what this looks like from a deployment perspective. And I got this diagram here. And what you can see here is this is what your local deployment looks like, your local development. We just load everything into one host. Everything is activated and everything loads into one host, okay? But it's really easy to have two hosts, right? You can have one host here with your background workers and activate the background services here, and another host with your API endpoints and just activate your API endpoints here, okay? Well, what if you want to do it differently? You can, right? You can do your background workers in one host, your API and reporting, endpoints in another host, and your admin API and controllers in a totally different host, right? And then now you can secure and scale these hosts separately, right? And let's take a look at this configuration where we break everything out into separate hosts. So again, the same container, right? Same binary code, same container. We can just at runtime configure it, right? With the environment variable to tell it which services to load. So we can have one host that's just monitoring the work items, one host that's monitoring the status of the project, right? And we can have a host that's doing the admin controller, a host that's doing the reporting endpoints, and a host that's serving the rest of the API. And we can now scale these, secure them completely independently, exactly as if they were microservices, right? But they don't have to talk to each other, and there's no service boundary because all of the dependencies are directly linked, okay, at build time, right? Really nice, okay? Now, one of the common points of feedback is, okay, well, what if I need to scale my database, right? Because one of the tenets of microservices is really separating and isolating the databases so you can scale them and migrate them independently, okay? Now, what people really don't think about is like relational databases like Postgres, SQL Server, MySQL, they are tremendously scalable. And they can scale in a variety of ways, for example, through sharding, right? They can also scale just by creating replicas for reads and writes, okay? So take a simple example is, let's say our reporting is very heavy, right? Well, if we want to be able to scale that independently, one of the things we can do is just create a set of read replicas here. And instead of pointing our reporting controller to our write instance, we will just point it to our read replicas and replicate the information down into our read replicas. And this way we can scale our reporting, which is going to be more intense, right? We can scale our reporting independently of our writes, okay? And for even more performance, you can also just do a transformation on the way out, right? So you can just project the information into the flat data sets that you are expecting to serve, right? There's no reason that you have to do a direct and a raw replication, right? You can just project it. You can put it into another database. If you want to push it into Snowflake, push it into Snowflake, right? There's lots of ways you can scale your application that doesn't involve you creating, separate databases just because you have separate services, right? You're working with the same data entities, right? It does require a little bit more discipline and coordination, especially as teams get larger, to update the database schema. That is 100% true and valid, right? But for small teams, there's really absolutely no reason that you can't scale your application as a modular monolith just by scaling out your database into replicas as a very, very simple, basic example, okay? Okay, so I think that's probably the end of this, and I hope it was useful for you to understand how to do this, right? And why it's going to make your life significantly better, right? If you're dealing with microservice hell today, especially if you're a small team, right? Take a look at this and take a look at the concepts here and really focus on, what the Google team wrote here, which is, this idea of separating how you write the code versus how you deploy the code. And the solution pattern will look a little bit different depending on whether you're doing .NET or Go or Rust or Java or Node, right? It's going to look a little bit different depending on which of these platforms you're on. But at this, I don't think it's going to be that different, right? You're really just saying, okay, at runtime, I'm going to configure the modules that I actually want to load and execute, as opposed to, trying to, at the repository level, in the worst case, right, separate all of my different modules into different repos. That's really, really painful. Do not do that. You will hate yourself if you do that, okay? So check out the Google paper. The title of the paper is Towards Modern Development of Cloud Applications. It's a really great paper if you want to make the case for a monolith. Check out this repo, because this repo has the purpose of this repo is to provide you the scaffolding for a real and practical application that you can take and make your own, okay? It's so close. The only thing I didn't put in here, I didn't put in authentication, right? But that's really easy. I've hooked up everything else, all the endpoints, all the routing, all the loading. Take a look at how simple it is, okay? And what I've tried to do is really make this easy for teams to adopt. There's a whole write-up and a whole article. So if you go to this link here, you'll see there's a whole write-up on this particular talk that gives you the insight in the background and the technical background of how to do this, okay? Including diving into the CS project configuration on how to do this and make your life easy to minimize the amount of manual work that you have to do, okay? And then this repo has all the documentation, commentary, and notes to make this really easy for you to get started, okay? I have a quick reference of all the commands, instructions for running the samples, and how to run the unit tests and how to test it yourself to make sure you're getting, exactly this right configuration. And then the notes on how, multiple web service APIs are set up within this scaffold, okay? So if you're a .NET dev, this is perfect. You're ready to go. And hope to see it out in the wild. And if you love it, leave a comment below. Leave a comment in the repo. If you have any questions, leave a question below. Ask it at the repo, and I will try to answer your questions. And I hope that you found this video useful for your journey, towards modular monoliths. And we'll check in next time. Like and subscribe if you like detailed, deep dive, technical videos like this. Like and subscribe, and we'll check out next time.